Hello friends, in this video we're gonna discuss about relativistic transformation and addition of velocities. Before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta, right? So now you see, suppose we have two coordinate system S and S dash, okay, and let me assume that this S dash frame is moving along x-axis. This frame is moving along x-axis. Let me draw here. This is moving along x-axis, okay, with velocity v, suppose with velocity v. Okay, here we have considered this S is stationary, right? And you see, let us consider a particle. This particle, let it be moving with initial velocity u in this frame relative to this frame, S frame, and with respect to this S dash, its velocity be suppose u dash, okay. So now this u must have three components along x-axis, y-axis and z-axis, right? Ux I cap plus uy j cap, we are considering in space, okay, in 3D, okay, k cap. Similarly, u dash, the velocity relative to this S dash frame, that's gonna be ux dash I cap plus uy dash j cap plus uz dash k cap. That's what we're gonna have, right? So we have considered these are the velocities of the particle in two different frame. In S frame, this is the velocity. In S dash frame, this is the velocity, right? Hope you have understood this. Now let me write all the things properly what I have considered here. So these are the two coordinate systems, okay, S and S dash, okay. So this is a particle, its velocity is u with respect to S, and its velocity is u dash with respect to S dash frame, right? And the S dash frame is moving in x direction, okay. Let me write here. Let there be two coordinate system, one is S, another is S dash. Suppose S dash is moving with velocity v along x-axis relative to S, okay. Let a particle be moving with velocity u, velocities u and u dash respectively with respect to S and S dash, okay, right? Then you see, let me mention one more thing. Is this, sorry, it's supposed to be S, okay. So this S dash is moving relative to S along x-axis, okay. So now this velocity in space, this u can be written in this form, that u is equal to, it must have x component, y component and z component, okay. So hope you know this representation of vector ux I cap, uy j cap, uz k cap. Ux is the x component of u, and uy is the y component of u, and uz is the z component of u. So this is in S, in the frame S, and in this in the frame S dash, u is equal to this is u dash, ux dash I cap plus uy dash j cap plus uz dash k cap. So this is in S dash frame, okay. Now let me take a new slide. Before that, let me write here. So now you see, ux, this velocity, this is component of u along x-axis. So it will be given by the time derivative of x, right? Time derivative of x. Now suppose the displacement of this particle is x, suppose along x-axis, then its velocity, x component of velocity will be given by time derivative of x, right? So similarly, uy is the component of u along y-axis, so which will be equal to time derivative of y with respect to t, and similarly uz is equal to time derivative of z, right? Hope you have understood this. So similarly ux dash will be equal to time derivative of x dash, and uy is equal to time derivative of y dash, and uz is equal to time derivative of z dash, right? So that means what actually, here you see, so x, y, z, t coordinates of the particle in S frame, and whereas x dash, y dash, z dash and t dash coordinates of the particle in S dash frame, right? Hope you have understood this. Okay, so now let me rewrite all this component. Let me take a new slide first. Okay, so just give me a second. So before I go to next slide, let me tell you, though I have not written here, so ux dash is the component of u dash ux is the component of u dash along x-axis, okay? And similarly uy dash is the component of u dash along y-axis, and similarly uz dash is the component of u dash along z-axis, right? Hope you have understood this. Now here you see, according to the Lorentz transformation, if we use the Lorentz transformation, first let me draw the diagram here. Okay, now according to Lorentz transformation, you know that x dash is equal to x minus vt divided by 1 minus v square by c square, that's right? And as you see, this frame is traveling along x-axis, so only one coordinate will be changed, so that's why y remains yz remains y, and z dash remains z, right? Hope you have understood this. Now if you take the inverse Lorentz transformation, then what happens? This x should be written here, and this x dash should be written here, and this minus will be plus, right? This is inverse Lorentz transformation, right? So let me write here properly. So according to Lorentz inverse transformation, Lorentz inverse transformation, we can write x is equal to x dash plus v into t divided by root over 1 minus v square by c square, and y remains y and y dash remains equal, and z and z dash remains equal, right? Now the transformation of time will be like this: t is equal to t dash plus vx dash by c square divided by root over 1 minus v square by c square. And where c is the speed of light, speed of light, right? So now let me clean these things. So let me clean the diagram as well. Okay, now what we can do, let me define shift. Okay, just give me 1 second. Let me divide this space. Okay. Right, now you see here, you see this v is not changing with time. Okay, actually this s dash frame is moving relative to moving with speed v relative to s, moving with this constant speed. This v is not increasing or neither increasing nor decreasing. Okay, let me consider that way. Now if we differentiate both sides, this relation, let me differentiate all the relations here, transformation equations. Okay, differentiating this transformation equations, what we can do here, you see, let me copy this equation first here. So this is one transformation equation. If we differentiate both sides, here dx will be equal to dx dash, and v will be taken as constant here, dt, and that's it. Okay, this term will be taken as constant as well, right? Similarly, if we take this relation, this equation, then here we're gonna get dy is equal to dy dash, and similarly this one dz will be equal to dz dash. Okay, now let us take the this relation, then what we're gonna have, let me write on this side. Okay, if we differentiate, then here we're gonna get dt dash, and here v is fixed, so here dx dash. Okay, that's what we're gonna have. So we have differentiated all these relations, right? So now you see what we can do from here. Now let me copy this, let me take a new slide, let me copy all these relations. So here you see, now you see from equation 1 and 4, what we can write, we know that ux is equal to time derivative of x. So from 1 and 2, this is dx and this is dt, right? So if we use these two results, then what we can have, this. Let me copy these two results, just give me a second. So now so this is what we have got. Okay, now these two cancels, right? So this is going to be equal to, after cancelling this, we're going to have this thing. Just give me a second. So it turns out to be like this, right? So similarly, from 2 and 4, you know uy is equal to time derivative of y. So that's why what we're gonna have, this. Just give me a second. So let me write this one here. because we need to simplify this one further. So let me write this one here. So time derivative of y will be equal to this del y dash divided by this. So let me copy this. Just give me a second. Okay, this is what we're gonna have, right? So hope you have understood this. So similarly, uz will be equal to dz divided by this again, right? So hope you have understood this. So now you see what we can do. Let me simplify all these things. So here I missed something here. So it's supposed to be t dash, okay? In equation number 1, this is dt dash, okay, not t. Let me correct it. Okay, here you see this is supposed to be dt dash, this is t dash, right? Here you see I forgot to give this t dash. Okay, now then this is dt dash, okay? So then this can be written this way, that derivative of x dash with respect to t dash plus v, right? So because derivative of t dash with respect to t dash, that's going to be 1, right? So here we can simply write v, and here if you take dt dash by dt dash, again it's going to be 1, then plus here we're going to have v c square and dx dash dt dash. That's what we're going to have, right? Hope you have understood this. So this is vc square. So then here you see this is nothing but ux dash, right? So we can write, let me write this one here, ux is equal to implies ux is equal to ux dash plus v divided by 1 plus v by c square, and this is nothing but ux dash, right? So now let me simplify this also, this one and this one. Okay, then what we're gonna have, so let me write this one here so that I can have enough space. Okay, so here this uy, this can be also written this way, that uy dash, sorry, by dt dash root over 1 minus v square by c square, this term gone up, right, by 1 plus v by c square, again we're gonna have dx dash dt dash, right? So this will be equal to this, uy is equal to, so here you see this term is nothing but uy dash then root over 1 minus v square by c square divided by 1 plus v by c square. Let me write this one properly, just give me a second, just give me 1 second. Okay, v by c square, and this is nothing but, you know, ux dash, right? That's what we're gonna have. Hope you have understood this. So similarly, this also can be written as, instead of uy dash, now we're gonna write uz dash root over 1 minus v square by c square divided by 1 plus v square, sorry, v by c square into ux dash. But here you see, in all the three cases, here we're gonna get ux dash. Okay, hope you have understood this. Don't make it don't change it. Okay, so now here you see, so these three are the required results. Okay, these are the transformation of velocities. Okay, so these are the required results. This is c square. Okay, hope you have understood this. And last one is this. Okay, so this is all about transformation of velocities, relative transformation of velocities. So thank you for watching. See you in the next video.